conducted by Chennai chapter and the southern region. So to get things started, may I now request Mr. D.G. Benagappa, Honorary Secretary, IIF Southern Region, to welcome the gathering.
Thank you, Vignesh Ramanan sir. Good afternoon, everybody. It's my proud privilege to welcome you all for the day, for the function. So this is the joint technical session organized by SR and Chennai chapter. I would like to thank, welcome Mr. Muthukumar sir, chairman of SR, and the speaker, Mr. Rahul Khajure, lead supplier quality Volvo Group India, a eminent speaker to speak about application of quality tools in problem solving, which is I think it's a new technology available for us to adopt. So welcome you, sir, Mr. Rahul Khajure, sir. Welcome you, sir. Welcome you for the technical session. I also welcome Sektivelu sir, chairman of Chennai chapter, Vignesh Ramanan sir, honorable secretary Chennai chapter, and all the participants, past presidents, past chairmans of IIF IIF Chennai chapter, and SR past chairmans also. So now I request Rahul sir to take care of Rahul sir to go ahead with the presentation. Thank you.
Yeah.
Thank you, Benagappa sir. Sir, Rahul sir, just a minute, sir. So to take things forward next, we request Mr. Siddharth Anbudselvan, Chennai Center Council member, to introduce Mr. Rahul Khajure to the gathering, please.
Hi Vignesh, thanks for providing me the opportunity to introduce a really well accomplished speaker to Mr. Rahul. Network quality and Ferris Foundry lead auditor.
Sir, the volume is not so loud.
Oh, am I audible now?
Yeah, you're better now. Yeah.
I'm sorry about that. Okay, so just a few words about our speaker. Mr. Rahul is currently the lead supplier network quality and Ferris Foundry lead auditor in Volvo Group India. He has more than 14 years of experience in casting development and quality in automotive and engineering industry. He has worked with multiple top companies like L&T, Fozico, and PT Castings. A metallurgical engineer from College of Engineering Pune, started his career in foundry and being foundry auditor at Volvo, and has had an opportunity to audit multiple foundries across the world. In June 2022, Rahul, along with Brakes India foundry team, launched world's first green casting with least carbon emission from manufacturing. A strong believer in making right choices today for a better world tomorrow. We welcome you, sir. Please, we hope to have a great session with you.
Thank you, Siddharth. Rahul sir, the stage is yours, sir.
Yeah, thank you, Siddharth. Thank you, Vignesh, and thank you, Mr. Benagappa ji. First of all, thank you also Indian Institute of Foundrymen for an opportunity for me to come to the forum and share my views about the most common spoken topic on the problem solving in a foundry. You know, there are many quality issues which we as a customer discuss quite frequently with the foundries, and we as a customer also have a aim to achieve zero defect at our facility, and that is possible with the support of our supplier partners. It is not possible without the support of our supplier partners, and I think in that direction is important to discuss on this topic. I think we all are working in a foundry, and it's known majorly what exactly has to be done to resolve the quality issues, the day-to-day casting quality issues and all. But maybe it's good to review what are the basics about the problem solving methodology. So I thought to share some basics about the process. So let me share my screen, and let me know once you guys are able to see my screen.
Yeah, the screen is visible, sir.
Okay, great. So
yeah.
Yeah, so let's start with the session. And the topic for today's knowledge sharing session is on quality tools for problem solving. As we are not having a live session, maybe we can define some rules because this is an online session. I will prefer to keep most of you on mute during the session. But if you have any questions or concerns, you can always use a chat box to drop questions or make a note so that towards the end of a session we can take those questions and concerns also. The session is for like 1.5 hours. I'm not sure. Should we have a break in between if it is needed? But let's see how we go ahead. We'll try to finish as soon as possible. And as we are having an online session, I would request in case if we have a disconnection because sometimes the power goes and the internet gets disconnected. So in case if it is happening, please wait for 2 minutes. I will reconnect for the session.
Perfect, sir.
So
Perfect. Yeah.
great. So with that, let's start the agenda. So the agenda for the session is I will be talking more few words about the problem. Basically, if the problem is clear, then it's easy to solve. So I will touch upon the problem statement, problem definition, symptoms, and root cause. Then we will have a quick look on the 7 QC tools which are used probably for the problem solving, not only professionally but we can use also on the personal side. And then we will also touch upon more in detail about individual QC tools, and then we'll summarize when to use these tools. So let's start with the agenda. So what is problem? So it's a known question, and I think most every one of us know what is a problem. So problem, as per definition, is an undesirable event or any gap between what is expected and what is obtained is called as a problem. So if you are moving from point A to point B and you are not able to reach point B, that's a problem. And you are putting an effort to reach that point B by understanding what went wrong and all those things. That's the problem solving. So any effort to reduce the gap is called as a problem solving. uh, Session is at 2 o'clock. I can understand it's a post lunch session. It will be difficult for me to keep everyone interactive in the session, but I have some videos. Let's maybe start with the energizing video on what exactly problem definition means.
How do we know that the problem we're trying to solve is actually the right one? We can be very busy working on a specific challenge without realizing there might be a deeper problem. From time to time, it's important to step back and think about the problem from different angles. It can be really helpful to see things through fresh eyes to make sure we are really focusing on the key issues at hand. The problem definition tool is a simple yet structured framework that helps to open a problem up so that you can view it from different perspectives to find innovative solutions. It encourages you to think clearly about what exactly you're working on. It is a way of considering other factors that might have nothing in common on the surface. Jaya works for a children's charity in East Africa. A very pressing challenge for Jaya and his colleagues is to help children to get better access to information and technology. Less than 10% of people in the region use the internet. Jaya thinks that improving access to it will empower children and the wider community. To be able to address this issue effectively and begin designing a solution, Jaya and his colleagues start to examine the problem using the problem definition template. They think of what it is that's making them take action. They note down all the people that are affected by this. Jaya identifies the things that currently stand in the way. Are there any examples from other places that they can learn from? Can they think about the problem from a different angle? Jaya has been able to see that there are more factors contributing to the problem than he had originally thought. By reframing the problem, a possible solution has taken shape. He and his colleagues decide to pilot solar-powered computer kiosks that will serve as information access points for young people and their communities. The kiosks will be made out of scrap metal and attached to the outside walls of local youth centers. This can help to make the internet a part of children's everyday life and help to empower them and their families. The problem definition broadened Jaya and his team's understanding of the issue by opening up new possibilities. Reflecting on all the issues involved helped them to see things in a new light and develop a potential solution that can change their communities.
Yeah. So understanding the problem is important. Defining the problem is important when it comes to the problem solving methodology. But regularly, what we see in our day-to-day life, whenever there is a problem, we see there is a blame happening. Okay, it's operator mistake or inspector mistake or person has missed something, and that's what in some of the cases are happening. So it's important not to have a blame game whenever there is a problem, and people we need to understand that people make mistake, but it is a deficiency in the process that caused the problem to happen. So it's not always a man mistake, is also a deficiency in the process which cause a issue. So we have to think beyond what exactly happens whenever there is a problem. Taicho Heino, who is the father of TPS, has said once that no one has more trouble than the person who claim to have no trouble. So having no problem is the biggest problem of all. And what we see is we have to take it as a positive aspect, and problems are always a treasure for improvement. It's an opportunity for us to resolve something and improve the efficiency and productivity of the process. So if there are no problem, then it means there is something wrong. But once everything is resolved, obviously there should not be any problem. But usually what we see, the major pitfall in a problem solving is problem is not clear. Problem definition is not clear, or there is no data. Uh, in some of the cases, customer says, okay, the part is not fitting. Miss, why not fitting? What dimension having a problem? Which hole having a problem? Is it meeting part issue or what is the issue? Is sometimes the definition is not clear. Similarly, in most of the cases, we jump into the solution without analysis. We perceive, okay, this can be some other problem, not because of us. It can be customer issue also, and we tackle sometimes the wrong cause. In some of the cases, people blame each other. It's not my problem. It's maybe a machining issue. It's not a casting problem, or is some other assembly or child part supplier issue. We neglect people in the process, or we try to solve everything at once. We know sometimes there is a one quality issue, but team try to solve everything connected to the issue. So we are losing our time, and then we are not able to solve the problem efficiently. And as in some cases, the wrong peoples are involved while solving the problem. So these are the major pitfall when it comes to the solving problem. So in a process control, what does a problem solving mean? We need to understand when the part reaches a customer, or within a foundry or within the stakeholder, the inspector measures the product with the actual performance, and he compare with the standard, and those compares are established standard. As an example, you have a drawing, and the inspector measure the whole diameter with respect to the given dimensions. So if the dimension is okay, it means the part is okay. But when it compares to the standard, if the product is not meeting the requirement, or feature is not meeting the requirement, it means it's not okay, and it demands the correction in a process or correction in the product. So this is what is a flow chart when it comes to the problem solving in the process control. When it comes to the let's understand what is the relationship between the problem solving and maybe the process improvement before we go to the quality tools. So usually, this is a typical graph which is a correlation between performance versus the time. You have the actual performance, and suddenly there is some issue happening, and that's what is a problem. the product feature is not within a specification and is going out of the specification. So this is what is a area where we need to act and resolve the problem. And what does it mean? So when you resolve the problem, it improves the process. It brings a change in the performance, and it update the standard. So problem solving not only can resolve the issue what we got, but also most of the cases it will improve the process, and it will avoid the reoccurrence of the same issue, because if the actions are correct, it will uplift the standard and it will uplift the performance what we have on the process. So let's go more in detail about 7QC tool. So most of us in the quality in the Foundry, we know what are the 7 quality tools. So this is nothing but problem solving methodology which we used to collect the data, analyze the data, and focus on what exactly is the issue. We try to analyze the root cause, and we try to conclude what is the reason of occurrence. And with this tool also we try to we measure the effectiveness of the actions what we have taken. So these are the few major aspect when it comes to the 7QC tool, which are populated by Dr. Karo Ishikawa from Japan. So the 7QC tools are very basic tool. It doesn't need to have a very sophisticated calculation and all. So with the basic training in a statistic, anyone can use this tool, not only professionally but in our personal life also. We can use this tool to achieve something. If you want to achieve, if we are stuck somewhere and if you have some problem, we can use some of the tools to understand the issue and then resolve. So these are the major aspect of 7QC tool. When it comes to the 7QC tools, what are those tools we are talking about? These are the tools. So in today's session, we will be talking about check sheet, scatter diagram, histogram, stratification, control chart, Pareto chart, and cause and effect diagram. So these are the 7QC tools majorly used for solving the problem in a day-to-day professional life. We'll go more in detail about these tools in the coming slide. Before we jump to the tools, so all these tools are majorly classified that in a different aspect. So there are some set of tools like check sheet, stratification, or scatter diagram. These are used to collect the data, and some of the tools like control chart, histogram, this will not only collect, or we will get the data from the check sheet, and we will try to analyze the data with this chart. And if you want to uh, uh, conclude on the root cause of occurrence and all those things, then we will use a cause and effect analysis and Pareto analysis. So let's go more in detail about individual tool. So first tool, what we are talking about is a check sheet. So check sheet we use in day-to-day life, in the process control, in the product inspection, or even in the final inspection. So check sheet is a sheet designed in advance to allow easy collection and aggregation of a data. So it's a simple format, and there is a clarity what has to be collected, how it has to be recorded, and it has to be is should be simple for a operator or inspector for an individual to record the data. By just entering the check mark on the check sheet, data can be collected to exact necessary information, or through inspection can be performed in an efficient manner. This check sheet is also effective in performing stratification once we have a data collected in a check sheet. So that's all about check sheet. It's very simple aspect. Anyone can use it, but how to use it is important. So first of all, it's important to decide on the format. What is that format the individual is going to follow? What is the data he or she is going to collect, and what is the way the data will be representing in the check sheet? So important is to decide on the format, then decide on the factors which has to be measured. We can't ask operator like to measure everything, so there should be clarity what exactly has to be measured connected to the problem. The format also should be simple to collect the data in all the factors. Means this kind of a checklist should not have a open space where the operator or inspector has to write uh, the text or the information. So that is very time consuming job and is not efficient for him. So the format should be simple and easy for operator to collect the data. Uh, Indeed, there should be some space in case of any observations or concerns. Operator or inspector or an individual can give a comment or a remark against the data collected. Also, there should be a instruction on how to use this basically the check sheet and who will be in the position to update the data, validate the data, record the data and all. And towards the end, this check sheet also has to be validated by someone, maybe from a third person. There can be frequent audits and validation happening on the check sheet. So when we can use a check sheet, so let's see more in detail. uh, the usage is real time, so it has to be done with the camera. It means person has to collect the data real time physically. It means inspector, as an example, inspector in the shop floor having the dimensional measurement done or visual inspection done, okay, not okay, recorded. All those things should be done live. It also used for problem definition phase house to quantify the problem. So if you know there are many problems and if you want to quantify, okay, or if you want to prioritize which problem has to be acted upon on a priority, so the check sheet can help us. This is also utilized during various phases, as an example, to analyze and validate cause, or to implement a selected control measure, or to review the effectiveness of the actions taken, or to monitor the performance of the actions which are already taken to resolve the quality issues. So check sheet can be used in any phase, from the process control point of view, product inspection point of view, before the problem occurrence or after the problem occurrence, or probably during the implementation of actions and validation of action. So what we get as a result is we quantify the problem with the check sheet, which as an example, which process is disturbing the product quality. So we quantify the problem. We also try to get root cause validated, and we also try to validate the corrective actions which are implemented during the journey. So that's what, as a result, we get from a check sheet. Check sheet is also a source of data that can be visualized with the help of a Pareto or bar graph or histogram. Once you have a data that has to be visualized, if it is mere data, it is difficult for a third person to understand and conclude or define the direction way forward. So this will be a basis to do the data analysis in the form of visual management with the help of Pareto, bar graph or histogram. So here is one example. It's a simple example. You can have the 2D matrix where the problem can be defined. As an example, the inspection in terms of the scratch or dent or other thing, day wise, time wise, shift wise, or the operator wise can be collected, and accordingly the sum can be visible. So this is a simple format used majorly in all the companies. Let's go to the next on the stratification. So once you have a data, those data, if we can analyze in a simple way, for that we need to do the stratification. Also, when there is a huge amount of data, means there are many numbers available, but it's very difficult to classify, sort the data and all. So that time stratification is important. Stratification, what does it do is basically divide the whole of a data into smaller portion according to certain criteria. We have to define the criteria, and then collect the data based on the smaller groups. As an example, one table over here, which is a stratification of problem. So there's a problem of multiple telephone interruption. There are three major reasons classified. Usually person gets a wrong number calls, or there is a many calls he or she is getting on getting some information, or there are many calls coming from a boss. So if we classify the reason and collect the data with respect to the reason, and with respect to the day, then it gives a clarity, okay, which is the area troubling a most. So with the stratification, now we have a clarity, okay, there are more than 40% of problem because of a wrong numbers are coming, wrong calls coming from unknown numbers. So that is the area which has to be acted upon. And then next was many calls coming from a boss. So accordingly, the actions can be defined. So this is what will be visible. Instead, if you just collect the data in a check sheet, may not be very clear, and with the while collecting the data itself, operator or the inspector can get a visibility of what is the area of a concern in the stratification. So when exactly it is used to observe variation among the data. So what we do is you classify the data with respect to the smaller groups and start collecting the data. With this stratification, we try to identify the relationship also between cause and effect. As an example, in the previous stratification graph, what we see is there are many wrong numbers calls happening, and that is what is disturbing the person working. So we try to understand what is really happening and what is the cause and effect. This is also used to identify purpose and also used to serve the purpose. And towards the end, what do we get is we try to understand the variation between categories, help to narrow the problem. We also try to validate the data in terms of the cause aspect. So stratification can be done in many aspects. You can define time as one of the stratification, like hours, uh, AM or PM or shift or working days, months or weeks when it comes to the collection of a data. So as an example, if there is a quality issue and we have to understand uh, there is a problem of a shrinkage or something and it's happening randomly, but we don't have a clarity. So what we do is we try to collect the data with respect to the casting production date, or if you want to go deep, you want to collect the data with respect to the in which shift those problems are happening, more rejections are happening. And if you want to go further deep, you can also connect who are the operators working in that particular shift, or the process, who is a operator or is the individual driving the process and all. So we can go deep in terms of the stratification. So it can be with respect to the time which is majorly followed, or it can be with respect to the people based on the based on the work profile, based on the gender, based on the number of years of experience, and newly joined employees or experienced employees, and so on. It can be also with respect to the work method, based on like you have a melting area, you have a molding area, you have pouring area and all. So you can have a stratification or data collection with respect to the areas also, and so on. So there are many areas we can define our own criteria to collect the data when it comes to this stratification. So as we see in the same example, it also gives a clarity that 40% of issue is because of wrong calls, wrong number calls coming to the desk, and which has to be acted upon. And second priority is also many calls coming from boss. So simple action can be to avoid the many calls from the boss, to have a be a live meeting with the boss frequently in a day, and avoid the phone calls. So stratification also gives us a direction to prioritize which are those areas has to be acted upon, and what also can be the action to resolve those issues. Next, next QC tool, which is most commonly used when it comes to the AD or the quality issues raised from the customer, is a cause and effect diagram. This is also called as a Ishikawa diagram or a fishbone diagram, which is nothing but a systematic representation of a relationship between effect uh, and the factors causing the effect, which are nothing but called as a causes. So there can be many causes for effect, and this is what the fishbone diagram or the Ishikawa or cause and effect diagram looks like, where you have a problem and there are many reasons for those. Those can be with respect to the 5M aspect, man machine method and all, and those aspect also be connected to the many causes. So Problem solving is a scientific method. Solving a problem is a scientific manner requires a clarification of a cause and effect relationship. So we need to understand what is a real relationship between the various causes and the effect what we get on a product or a features. So when exactly this has been used is when we want to clarify our cause and effect relationship, or if we are in a initial development phase, we want to uh, define a phase and analyze the reason of occurrence, or also to develop the countermeasure. We know sometime nowadays people are using cause and effect diagram even in FMEA before the problem occurrence. So this also can be a, potential tool to predict the occurrence or the potential occurrence when it comes to the problems or the issues in the product. Typically for cause and effect diagram, we use a 5M or even a YY analysis. When you want to define the many causes connected to the, as an example, machine, we can also do the 5M or YY analysis or the other aspect. So towards end, what we get is overall result is very clear, and visually it is clear what can be the potential reason, and it gives a trigger to act upon the potential reasons of occurrence. This also clarifies the cause and effect relationship. We are able to understand how is the relationship between the various causes versus the effect and also their impact. So in terms of the weightage also it can be clear, and this is also useful to list upon the various possible causes. So there may not be hidden areas or missed areas which is not explored. So this bring more visibility in terms of the defining the causes. So in terms of visibility, it is more good, and we get more clarity when it comes to the various potential reasons of occurrence. So as an example, this is one general example what I mentioned. uh, for a printer, uh, sometimes we face many uh, printing issues. We put a print screen or print button, but still the printer is not working, or you have some error, or you don't get a print. So what can be the potential reason? There can be man issue, machine issue, or method issue and all. So there can be issue also with respect to the product. As an example, the quality of a paper, the papers are folded in the trays, or papers are too thin, or paper there are no papers in the box, or sometimes you someone is loading only few papers, so it's getting printed and you don't have a stock. So there can be issues, or there can be user issues, wrong selecting the keys and other one, so on. So what we get is basically visually we get a clarity what are the potential areas of a concern and which can cause a problem. So once you have this kind of a diagram predefined and created for a problem, as an example in a foundry, which is the most common problem of inclusion or porosity, if we define the potential causes, and when you get the issues from the customers or internally, this kind of a predefined cause and effect diagram can be helpful, or can be a ready reckoner to immediately act upon or resolve the issues. But unfortunately, in most of the foundry, we work with the experience where people think, okay, I know this can be a problem, I know that can be a problem, or molding is a problem, or we have some kind of judgment. But it's always good to have the cross-functional discussion done, and define the Ishikawa diagram or cause and effect diagram whenever there is a kind of a quality issues, or there is a problem occurring in the foundry on the product. Next important tool is a Pareto diagram. So this is also called as a 80-20 on general terms, also called as ABC analysis. So the general aspect is 80% of problems are attributed to 20% of causes. So this Pareto diagram is nothing but a combination of a, bar graph and the line graph with the accumulated data. So what we have as an example in this graph is there is a data associated with a problem here in the bottom, and are divided into smaller groups based on the number of occurrence, and then we get a graph and towards the end on the right side we get a cumulative figures. This also gives a clarity which are the areas has to be prioritized. So Pareto is basically a name came from the Italian mathematician who is the creator of this diagram. So this distinguish between the vital few and tribal many. It means we have a clarity which are those top two or top three areas has to be focused upon to resolve or to get a maximum benefit in terms of the reducing the rejections or solving the quality problem. As an example, in this particular graph, there are two issues, that is missing label or cap missing. This contributes to maybe approximately 80% of a problem, and if these two are been resolved, we are reducing drastically the issues what we are getting in the product. So on the usage, so Pareto diagram cannot be plotted without a data. It means we need to have we need to use other tools to collect the data. So we may need to use a check sheet or stratification sheet to collect the data. And once we have a data available, then only the Pareto diagram can be plotted. We also need to have a good amount of data. The Pareto cannot be plotted with small data. It has to be quantified good data. So Pareto can be used in three different aspects. In terms of the problem definition phase also, you can use a Pareto to basically identify and prioritize the problem. As an example, you have many issues in the foundry in terms of the casting rejection. So which issue has to be acted upon on a priority? So for that, we can use a Pareto, which many of us are using in the foundry. So this is one area where we can use a Pareto. When it comes to the root cause analysis, Pareto can be used to identify most important causes. Now, as an example, we know there are quality issues or quality complaint from the customers, or there is a blowholes or porosity opening after the machining. So we are trying to analyze what exactly are the reasons of occurrence, and based on that we can also plot a Pareto to understand the root cause. So this Pareto also can be used to analyze the root cause. Also, this can be used in the solution phase to basically effectively monitor the performance of the action taken. So if the graph is Friday versus Monday, or the past versus new graphs are different, and the results are positive, will be effectively visible with the Pareto. So the Pareto graph can be used in all the phases, but we need to collect the data. It means we need to use a checklist or some kind of format to collect the data. What we get with the help of Pareto is we allow the clarification of important tasks. We allow identification of a starting point. It means where we have to focus, which area has to be prioritized, which issue has to be prioritized. So we get that direction, and it's also allow the projection of the effect of a measure to be taken. It means what exactly we have to do, we get a direction and clarity also. From Pareto, what I mentioned, we can also effectively monitor the performance of the action taken is also visible with these two graph. So as an example, this was a graph before you have taken action, and if the actions are effective, then those variables either will get eliminated from the graphs or will get reduced. So effectively, the performance will be visible in the graph, and we see the improvement in the Pareto. So usually in most of the companies, we follow Pareto when it comes to analyzing the problem, but we don't follow the Pareto for monitoring the performance or effectiveness of the actions what we have taken. But this is also equally important to plot the graph to understand the effectiveness of a performance. So this is all about Pareto. Moving on to the fifth quality tool is a control chart, which are majorly used when you have a huge data. As an example, in the molding area, you have a sand properties. Uh, we can use a control chart, or you have seen in machining areas also, where the process capabilities are needed, or there are critical dimensions. Data has to be the feature has to be inspected, and there is a huge amount of data available against each part or for many parts. So when you have more data, the control chart can be plotted easily. So control chart is a graph used to study how the process changes over the period of a time. Is it stable? Is it non-stable? Is going beyond the limit? So we get a clarity, or we get visually some direction how stable the process it is. So in this process, in this particular quality tool, data are plotted with respect to the time. With the course of time, the data is plotted. As an example here, maybe the if there is a dimension, or the whole dimensions, or the very thickness dimension, those data are measured with respect to the time. As an example, the product produced today, product produced next hour, or with respect to the serial number, and so on. So we have a graph with respect to the time, and that's what the trend is visible. So typically in this kind of a graphs, or in a control chart, what we have is there is a center line which is nothing but an average, and there can be upper or lower limit, which are basically the control limit to make sure that our feature what we are measuring and controlling are within the specification. Those upper and lower limit can be defined as tolerances on the product, or also can be a uh, uh, calculated process control dimension based on the standard deviation also. So those are aspect of the control chart. So when we have to use, what has to be obtained is when controlling ongoing process by finding and correcting problem as they occur, we can use a control chart. Control chart also can predict the expected range of outcome from a process, how the process goes on, and how the process looks like currently, and what can be the process performance in the future that can be visually identified in this kind of a tool. This may not be possible with other quality tools like Pareto, or the maybe simple stratification. Uh, Prediction of performance of a data may not be possible with the other quality tool, which is possible only with the control chart. Uh, Also, control charts can be used to determine whether a process is stable or not, that as I mentioned. And it also can analyze a pattern of a various variation from a special process, or that is a common cause or a special cause. So if there is a sudden change in the graph, it means there is something wrong, and it can be a special cause, not a common cause or a chance cause. So what, as I mentioned, in terms of the control plan, it is used to observe a change cause with respect to the time. As seen here, there is a movement in a graph with respect to the time. So we know how the process or the feature is performing with the course of time. So during phase to monitor the situation and analyze the cause, or review the effectiveness of an action, or perform standardization and implement selected control measures, control chart can be used. And as a customer, or even as a foundryman, we always recommend, and we all in most of the foundries are also following the control chart when it comes to the molding properties or sand properties, because those are very vital in terms of the process control. If the sand properties are not okay, you know what is the impact. So those are the areas where control chart are being followed, but it's equally important to monitor and take the action. I have seen some of the foundry where the control charts are being followed, but those are not being analyzed. Those are not being taken seriously when it comes to the actions. So this is a very good tool when it comes to the predictive quality. Here, based on the trend chart, we can understand there is something wrong, and there can be proactive actions taken to avoid the occurrence of a problem. So control chart can identify the change caused with the time, and also can judge the process if it is in the normal state, or there are some abnormalities happening with the course of time. So this is one example where you can see there is a upper limit, there is a lower control limit, and there's a average limit, and this is how the performance of a product looks like over the period of a time. What we see is there is a sudden peak happening. So sometimes the feature requirement are going out of the specification. So this is called as an unstable point. Means we have a certain peak and then something going beyond the specification, and then we are taking certain action and making it within a specification. Whereas we also see sometime trend which is unstable in nature. So there is a control limit here, and what we see is the trend is coming down. So this is the time where we have to act upon and correct the process and redefine the average. So control, in case of control chart, these are two important aspects. Unstable point or unstable trend has to be monitored, and the actions in that direction has to be taken. So as I mentioned, molding is one of the area where this has been followed in most of the foundry, but there are other areas also where this can be followed in maybe in terms of the chemistry, in terms of the um, time, pouring temperature, pouring time, or many more variables. So it is effective and it gives a trigger for the operator or inspector to act upon to resolve the issue before it occurs. Moving on to the next quality tool, what we are talking about is a histogram. So uh, histogram is different compared to the bar graph, but it looks similar. There's one example here is shown. So it is basically a range of data divided into smaller section having a uniform span, and the number of data contained in each section is counted to develop a frequency distribution. uh, I'm sure, like in most of the foundry, we follow this histogram or similar graph we create for these sign properties for AFS numbers and all. So we try to understand, is it a two peak or multiple peaks sand. So representation is more or less similar, but when we have a huge data, then histograms clearly is out of the box and definitely gives a lot of input. In our case, when we have many parts coming from a supplier in one batch, and if there are many rejections happening, histograms gives a good amount of clarity for us to act upon, and also defines clarity in terms of the prioritization which has to be acted upon. Graph is also formed from this table by using vertical bar. We can also create a graph or line bar graph or bar graphs, and each have the height proportion to the number of occurrence in each section here. So uh, when it is used and what results has to be obtained from the histograms are important. Let's see. So this histogram can be used only when the data are numerical in nature. So when you have a variable data, when you have a numbers, then only this histogram can be used. It cannot be used when you don't have a numerical data. It's difficult. We can still do it, but it will not be uh, easy to plot, and it will be also difficult to correlate the judgment. Uh, when it comes to the histogram, when you want to see the shape of the data distribution, uh, how normal the distribution it is, we have to use a histogram. This is also typically followed when it comes to the machining features and dimension to understand how normal overall performance it is. This is also used when analyzing whether a process can meet the customer requirement. You would have also seen this kind of a graph when we are plotting the process capability to understand how normal distribution the dimensions and features are. So this is used to access the actual condition of a data. Is also used to analyze a process to identify the problem point that needs to be improved by finding the location of the mean value or the degree of variation of a graph. This is also used during a phase to monitor the situation. The actions taken in terms of the performance efficiency are effective or not effective. So histogram can be used in that direction also. So as a result, what we get is we can effectively identify the location of the mean, how central the distribution is, how central or how is the variation with respect to the nominal condition. This is also useful to find out the scope of a defect by inserting a standard deviation and also identify the condition of a distribution. So I have one example here. As an example, you have data like this, maybe 40, 50 part data in terms of maybe a dimensions or feature. So how we need to plot a histogram is first of all we need to have a range created, which is basically the difference of maximum and minimum value. So once we have range, we also need to understand a number of intervals. So number of intervals are basically a square root of total number of data. As an example, here we have a 36 points or 36 data. So number of intervals will be basically a square root of available data. So now we get a number of intervals. So what we have to do next is we need to define the interval width, which is basically a ratio of a range versus interval. So we have a interval width of a 9. So when you have a defined as internal width, then we can see the data, and data can be calculated or also can be plotted in the form of histogram. So this is the same data which is visible in the table, but in the form of visually representable graph, which is a combination of a line and a bar graph. So what we see here is and what we can interpret here is there is a maximum variation happening for the interval limit of 12 to 15. So 12 to 15 variations are highest in terms of the division when it comes to the variation coming from minimum 6 to 24. So this is the area where which has to be acted upon, or if this is a normal, then there are other areas which has to be acted upon to correct the process. So we get a visually some clarity how the distribution it is and how the spread of a distribution it is. If the spread is also lower, then it's also good. But in this case, like the spread is also high, means you still have maybe 2 3 points coming much away from the nominal. It gives a trigger that we have to act upon the edges to make sure that distribution is more towards nominal. So this is all about histogram, and the last quality tool is basically a scatter diagram. So scatter diagram is followed. You would have seen many companies, especially in the working in the investment or financial agencies, using this scatter diagram. But it's very simple diagram we can also use. So basically, what does this graph does is a allows the identification of possible relationship between two sets of variable. So we have a data, many data. We have to basically plot with respect to two variables, and based on the distribution of this data, we can identify how relationship is in between two variables. Is it a positive relationship, or is it a negative relationship, or there is no relationship between the two variables? So this is the diagram which is used to understand what is the relationship between two variables based on the available data. So display, this is also a method of testing possible cause and effect relationship. So sometimes we perceive based on experience that yes, this is the reason, or this can be the reason for this problem, but that also can be validated based on a scatter diagram. We can collect the data. Is it, as an example, pouring temperature really important when it comes to the shrinkage in the casting? So most of us we know yes, it's important, but how it is related? Is it positively related, negatively related? It means if your temperature is higher, you will have more porosity. If you have less temperature, you will have more porosity. So porosity, so that can be analyzed when you collect the data and plot the scatter diagram. So this is used to, as I mentioned, is used to identify the relationship between two matters. Um as an example, as I mentioned, there can be relationship between temperature, pouring time versus shrinkage, or pouring temperature versus shrinkage, or any defect versus any process parameter. We can establish a
சரி, நீ
relationship.
10 நிமிஷம் முடிச்சு போனாலும் போலாம், 2 மணி நேரத்துல முடிச்சு போனாலும் போலாம், எவ்வளவு நேரம் வேணாலும். சரியா?
Yep. And this also it can also help us to establish a countermeasure based on their cause and effect relationship. So towards end, what we can say is this can identify what is a real relationship between cause and effect, or between two variables, and accordingly we it's easy for us to consider that particular variable for solving the problem, or we can omit the variable from the potential reasons of occurrence. So in terms of the examples, this is how some of the scatter diagram looks like. If you have positive relationship between two graphs, this is how it looks like. And if you have a inversal relationship, then the distribution of data will be in negative direction. If you don't have a correlation, if the distribution of available data is widespread and it's very difficult to define the relationship, then the graph will look like this. Uh, Also, there's a one more important aspect. If you want to define the relationship, we can also use a hell. We can also use another quality tool of stratification to omit some of the features, some of the data, and then define the relationship. So this can be unstratified. As an example, this is unstratified or no correlationship between two variables. But you can define a correlationship by omitting some of the data, and if we are able to build the relationship among the data, then it is easy and it is possible. um, as an example, what I can say is we can, if you have a porosity issues, and if you have distribution like this based on maybe the operator, we can omit some of the data based on the experience of our operator. If we know, like, okay, there are some operators which are high in terms of the experience, there are some operators who are newly joined, we can eliminate those data available with the kind of operator, and then probably it will help us to define the relationship between the operator experience versus the issue what we are getting. So use of multiple quality tool can also help us to define the direction. So scatter diagram is giving us a direction in terms of relationship between two variables or multiple variables. So now we have seen all the quality tools, 7 basic quality tools. When we have to use which tool? That's an important question. So in the direction, there are some recommendations. If you want to identify the problem or define the problem or prioritize the problem, we have to use graphs, basically to graphs or Pareto diagram to identify the problem. But when it comes to evaluation of results, we recommend to go for cause and effect diagram, histogram, or scatter diagram to evaluate the results. And when it comes to the standardization or a process control, then uh, control chart or even histogram or check sheet or stratification are important to be used to control the data and to monitor the performance of a data. So wherever we have this double circles, those are recommended or strongly recommended tools, and but these single circles are can be used. So when it comes to identifying the problem, Pareto is recommended. Defining the problem, check sheet stratification, Pareto is recommended. And if you have to record the facts, then same, but histogram or control chart also can be used. Whereas towards the end, as I mentioned, for standardization, for process control, as we do usually on the molding area, but also in other areas can be done. Control chart are helpful. We have seen many foundries now across the globe. There are plotting control chart on all the aspect, not only the molding but also the melting and pouring and even the post production aspect. The control charts are being followed because it this is one of the tool which is helpful to predict the performance of the process. So if you can predict the performance of a process, it means we can act upon and we can resolve the process before it goes out of the specification. So we are going towards end. So to summarize, check sheet is used to collect the data. Majorly, stratification is also used to collect the data, but we can process the data while collecting the data itself to give some direction. Pareto diagram is used to identify the current status versus the issue, and also prioritize the area to be focused upon. Cause and effect diagram is used to understand the relationship between the variables and the problems. Control charts are basically to use to identify the current status, how the performance how is the performance of the process, how is the performance of the variables. Histograms is used to understand how is the distribution of a data, how is the distribution of the process or the feature, is it nominal distribution or it's a spread distribution. So histogram is used to understand how is the if how is the consistency in terms of the process performance. And scatter diagram is used to understand the relationship between two variables or even multiple variables. Is it positive relationship or negative relationship, or there is no relationship between the variables, which also can be a input for a cause and effect diagram, or even for the other diagrams, or even for Pareto. So these are the major uh, uh, s- uh, summary in terms of the usage of some of the quality tools, 7QC tools. So to summarize, so 7QC tools are used for effective problem solving. um, it's not that it will 100% solve the problem. Definitely there is an importance of experience, which is also important when it comes to the Foundry as a technology, where you have many variables to play around. But 7QC tool will ease the job, will visualize the issue. However, as I mentioned here in the slide, it is not important just to say or just to use this tool, but it is important to know how and when to use this tool. So as summarized in the previous slide, there is a key feature of each tool. We have to use the right tool at the right time for the right problem. So it's important to know how and when to use them. Also, experience plays an important role, which we can't uh, say no, it's not important. But this is one simple video which shows how experience and knowledge of a tool is important for the problem which we face in our day-to-day life. So you can also come across the issue. Sometimes we are thinking a lot to resolve the issue, but sometime for some of the experienced guys, it will be very quick when they have a hands-on experience in terms of the usage of a right tool for the problems what we get. So yeah, that's all I want to summarize. And thank you for listening. And I wish good problem solving to all of you guys. And if you have questions or comments, we can take it now.
Thank you very much, Mr. Rahul. It was indeed. Sir, Mr. Rahul, there is a question in the chat box.
Uh, yes. So yes,
Seven.
yeah. Yes,
Please
Vignesh,
go
I
ahead.
can
Please
take
go ahead.
I can take this question, Vignesh. Yes, the
Yeah.
question is 7QC tools seems useful as a quality control. Could it be used for quality assurance in advance too? To this, the answer is yes. It can be used for quality assurance also. As an example, the control charts. Uh, those are very widely used across the industry when it comes to the quality assurance, because these are some of the tools which are predictive in terms of the nature. Before you get a process auto specification or variable going beyond the range, you get a trigger. Nowadays, in terms of the industry 4.0 and artificial intelligence, there are softwares available which will monitor the performance of a system. As an example, in a science system, the software will monitor the compatibility performance, and before it goes beyond the defined limit, you get a trigger in terms of SMS or in terms of the email notification, and it also gives a trigger for operator to correct the process, or a machine sometime will automatically correct the process. So it is helpful to in terms of the quality assurance also, and it's also helpful to control the process. I hope I answered your question from SSK. Yeah, I think I can take next one also. Is it possible to share the PPT? Yes, I can share the PPT. I have already shared it to our team. Probably Vignesh, you can share the slides to the team if they want.
Yeah. Sure. Any further questions? Yeah, thank you, Mr. Malakar. We will share it with you. You've got it. Yeah, yeah.
Yeah.
Anyone else? Any further questions for Mr. Rahul?
So actually, I have a question, sir.
Yeah,
Yes.
So actually, I have a question, sir.
yeah.
Yes.
So we just started our foundry, sir, like 2-3 months back. So, what are all the tools that you recommend, sir? Like to start with, to regulate the whole process and the to increase the productivity in that sense.
Could you
Uh,
please give us your the foundry, please?
Sorry, sir.
Your name and the foundry you're representing.
H4 engineering, sir.
Sorry.
Hello? Hello, sir.
Yes,
Hello.
sir.
Namaskar. My name is Surendra, sir. Hello?
Okay. Uh,
Sir, these are all the old quality tools. What about new quality tools? Hello?
yes, sir. I think you are from the same foundry, Dhanushekar
no,
and
he's from
Surendra, sir.
Vietnam.
Is it the same?
No, sir. No, sir.
Okay.
Sir, these are all the old quality tools, sir. What about new quality tools?
Yeah. Yeah, maybe I can answer this question first, and then maybe Dhanushekar, we can take your. Miss, both the questions are connected. See, the tools are the old, but even in the new time, in the new era, these are all the basic tools which are used even for Industry 4.0, even for artificial intelligence. So, or IoT is basically are using the same concept. So, what we were doing manually till date using the same tools, now there are softwares, machines to collect the data and analyze the data. Only major difference is, as we know, in many of the foundry we are recording the data for sand properties, as an example, compactability, permeability, this and that, but those data will be there in a paper. Unless and until there is a quality issue, will not, or no one will go back to the lab and verify those data or analyze those data. So that was a major issue that has been taken now by the artificial intelligence or industry 4.0, where the machine will keep on analyzing the data and keep on
Yeah.
predicting the performance of a process. So basis or the foundation remains the same. 7QC tools uh, though it's old tool, but these are the foundation even in the new era, used in the modern foundries, specifically to
Yes,
resolve the
sir.
same issues what we have.
New quality tools, sir. Regarding new quality tools, I'm asking. Hello?
Yes, sir. So
Hello?
new quality tools means specifically in which area you want to know.
Yes, yes.
So miss, in terms of the problem solving, there are other methodologies
Foundry.
apart.
In
Yeah,
foundry
yeah.
only, sir. Foundry division only.
Yeah, in Foundry, apart from this, see, it depends on what kind of a problem we have. Based on the kind of a problem, we can choose some of this tool, or you can also go for a next level tool. Means you can also go for PDCA or ADE methodology to
Yes, yes.
resolve the problem.
80, okay, sir. Thank you, sir.
Yeah. And connected to a question from Dhanashekar, see, as I mentioned, these are the foundation for all the tools which are nowadays available for foundries. The concept remains same, but as I mentioned, there is only the uh, 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 basically what we have is softwares now to do the data collection. You have IoTs to collect the data in terms of the person measuring or analyzing data. So, as an example, if we are talking about a new foundry, sand is important. The automation in terms of the sand properties are important, where the frequency in terms of the inspection is also important. So 100% compactability nowadays, you get a SMC installed for the mixture. So SMC, what does it do is you check the compatibility of 100% mixed batch. So if the batch is okay, then only the batch will get discharged. If batch is not okay, then batch get mixed again, or it gets rejected. So once you have that data, a machine will basically analyze how is the performance, and if you have a frequent rejections happening in process, which are you produce 100 batches, and in out of 100 batches 30 batches are getting rejected, it means it's a loss of time, loss of money, loss of efforts in terms of the resources like electricity, water and all. So that is the area which can be acted upon in process rejection uh, by this kind of softwares. So it is practically difficult for the operator to act upon, but it's easy when you have a data or triggers coming from the machine. So sand properties are important, but apart from that, melting related property, chemistry, time, pouring temperature. Yeah, maybe if you have ductile iron or the uh, SGRN, then you need to also monitor the magnesium recovery and all those things. So those are these areas which are important in terms of the process control. So process, if the process is robust, obviously the product will have a minimum issues. So we need to put, if it is a new foundry, we need to have a good amount of control for the in-process aspect when it comes to the sand and metal properties.
Okay, sir. Okay. Thank you, sir.
Yeah.
If there are any further questions, we can take, or we can move ahead.
Hi, Rahul.
Yes, sir, Balmurugan.
Hi, Rahul. This is Balamurugan from MEA. Thank you very much for your valuable presentation. I hope everyone.
I think there's a Miko Bala.
Hello.
Yes.
Yeah.
Hello.
Yes, Balmurugan.
Bala sir.
Yeah. Thank you very much, Rahul. It's a great, valuable presentation. I hope everyone can utilize this. And just we want to know what kind of tools to use for the problem. What are the foundry related problems? That is also you covered. If possible, you can just explain about the sand related properties. What kind of tools have to be useful for analysis?
Yeah, for sand related properties, see, all foundries are collecting the data. Their stratification is happening for the data, but control chart and histograms are important when it comes to the sand property. This has to be followed. If the properties are within the control limit, then it's easy to act upon, and it's easy to analyze. So I think the control chart and the histograms are two important tools has to be used for all foundries if you want to come out of the sand properties. So this is a continuous journey. So if your process is robust and standard based on your control limit, we can also explore to reduce the control limits to improve the efficiency of a process. So initially you can have a good or wide range of upper and control limit, but with the course of performance of sand property, then the range also has to be reduced and improve the process efficiency. So we have to follow control chart and histogram. Histogram is basically to understand the distribution, how widespread is the distribution of the sand properties.
Okay. Thank you. Thank you very much.
So with that, we've come to an end with the technical program. So, gentlemen, we have indeed had a very interesting webinar today. Application of these tools in problem solving. To ensure the contents of the talk important takeaway for our audience. We would like to thank Rahul Khajure, lead high quality, Wolf Group, for taking time off his busy schedule and making us rich with knowledge. Further, we'd like to thank all the members who joined us for the talk. I'm sure you had a wonderful learning experience, and thank you for joining us on time and being such a wonderful audience. We from the Chennai chapter will be conducting many such interesting programs, and we'll be sharing the information on the same with you. Looking forward to seeing you all in our upcoming programs. Thank you very much. Thank you, Mr. Rahul. Thank you.
Yeah. Thank you, Vignesh. Thank you, Foundry team.
Thank you. Thank you.
Thank you. Thank you.
Thank you. Have a nice day and nice weekend ahead.
Thank you, sir.
Yeah.
You too.
Bye bye.
Thank you.